Assalamu alaikum. Welcome to Turkish Engineering. In this lecture, we are going to solve a problem related to homogeneous reactions kinetics. So we have a complex reaction with a stoichiometry given as A plus 3B to 2R plus S. And this is a second order rate reaction. So you see here we have power of 1 and power of 1. So any rate of reaction is just the summation of the powers of the concentrations, right? So 1 plus 1, it is second order rate. And if we just remind the units of a reaction rate, it is just how many moles I'm consuming or producing from a species of a reaction, how many moles per volume, my volume of reaction or reactor per each second. Okay, so if we're talking about rate, we have always like divided by second, right? Per each time units. It can be minutes or hour or days. So this is our like reaction rate. And sometimes this meter cube you can see in catalytic reactions. We have, instead of volume, we can use mass of the catalyst. So it can be kilogram of catalyst instead of meter cube. But for this problem, we only need to relate the reaction rate relations of different species in a reaction. Are they related with the coefficients between them, or there is no relation between them? Since we have the reaction at the same medium, and if we produce 1 mole of A, for example, this has a coefficient of 1. At the same time, since they are like reacting to give us these products, at the same time, interval, let's say 1 second, if I produce 1 mole of A, okay, let's say Ra, I'm producing 1 mole per each meter cube second. I have the same volume, okay? So from this one, I should consume 3 moles per meter cube second. That means, since meter cube and second, the other units are like same time interval and same volume, right? So the reaction rate should be 3 times bigger for B. And these are the consumed species, right? These are the reactants. And these are like minus, we always lose. And products are going to increase by each time interval. So there should be a reverse relation between them. So let's start. Ra, if I know it, should be less than, right? Like Rb is like faster, is going to be like 3 times faster. So I divide it by 3. Just I divide by the coefficient, I put Rb. Okay, and since they are like gonna be consumed, you can plus minus. Okay, you can put minus here, minus, because we will relate it to RR, and since this is gonna be like increasing by time, to not get confused, put minus for a product, but it's gonna be increased by time, so we keep it plus, we keep it positive. Okay, RR. So you see that this has negative and this has plus, so this is the reverse relation between them. And RR has a coefficient of 2, so it should be like, it's going for each particular 1 mole of A species A, I should produce half of R, right? Because in this I understand it from stoichiometry. So this is the relation between the reaction rates. We have 2 things to know. Just one thing is coefficients. So coefficients of stoichiometry, if you have like bigger coefficient, that means you have faster rate. Okay, you have a faster rate. So if you send this guy to other side, you will see that Rb is gonna be 3 times bigger than Ra, right? You can also put like this, but to like use a standard thing that you always fix for the species that has coefficient of 1, you fix it, and the other of them you can relate it like this. Or always, let's say the first species, you can fix it, and the others will be just the ratio of, this is the coefficient of A, right? Coefficient of A. For example, if I have 5 here, 5 for the A, you will put just 5. Okay, you will put just 5 here. So this is the coefficient of A, the first species. And here coefficient of B and times the action rate. You put it like this. So this is the relation between them. Also, you can say 2 times of R, right? It will be positive and 2 times bigger than, I'm sorry, it is the relation between RB and RA. So you can say that R separately will be 2 times of RA. Okay, will be 2 times of RA. You can say like this. But as you see, it's not straightforward to make like this. So you just fix the first species, then put coefficient ratios to get them in one equation. Thank you for watching.